have understood SHM as projection of uniform circular motion on a plane. The body is moving a circle of radius r with a constant angular velocity omega, and we had found that is what is the displacement, that is this is body is executing SHM, or let's say this is a particle which is over here moving in a circle. The projection of this onto this screen is SHM. This is not SHM, this is SHM. How this motion, how this shadow is moving, that is SHM. So we can relate this motion very well to this motion where the body is executing SHM. And over here we also note that is y is equal to r sin omega t, that is Vy is equal to omega r square minus y square, that is velocity is maximum at the mean position over here in this direction and over here in this direction. The whole velocity is seen over here, whereas the velocity over at the extreme positions it is equal to 0. That is velocity along y-axis we say omega r square minus y square. What is velocity maximum? This is constant, r is constant, omega is constant, y is variable. When y becomes equal to r, then at extreme position this is r square minus r square becomes equal to 0 and velocity becomes equal to 0, which is observed on the screen. And when the y is equal to 0, that is at the mean position, then it is 0, so omega into r, that is the maximum velocity which can be seen over here. Now we come to acceleration, that is what is the acceleration which is seen on the screen. Now we know that is when the body is moving in the circle with a constant angular velocity, we have only centripetal acceleration. AC is, we know it is v square upon r. AC is v square upon r, or this will be if we put v is equal to r omega, because v is equal to r omega, if we put it over here, so it comes out to be r omega square upon r, it comes out to be r omega square. That is centripetal acceleration. So over here the centripetal acceleration is in this direction. What is the value? R omega square. So once again when the light is falling from here and this acceleration component as we did in velocity, so this acceleration component will not be visible, it's only this component which will be visible onto the screen. So if this is theta, so this is theta, so this component is AC cos theta and this component is AC sin theta. So the acceleration which will be observed onto the screen is AC sin theta. Now AC is what? AC is r omega square sin theta. So acceleration along y-axis. Acceleration along y-axis is r omega square sin omega t. So this is the acceleration which is seen on the screen. One thing also to be noted is when the body is going from here to here, the acceleration is in the opposite direction. So we say that is acceleration which is seen is r omega square sin omega t. So we say acceleration equal to minus r omega square sin omega t. So acceleration is equal to minus omega square r sin omega t. But r sin omega t is what? R sin omega t is y. So this comes out to be a is equal to minus omega square y. A very important thing, omega is constant, so it means acceleration is proportional to minus y. So what we observe over here, that is acceleration is proportional to displacement and it is oppositely directed, that is both of them they are oppositely directed. Like if we consider a simple case where this mass is attached to this spring and this is horizontal frictionless surface, if it is pulled from here and released over here, so this is vibrating within these two extremes. If it is displaced from here to here, so displacement is in this direction. Whereas when it is displaced from here to here, this has been pulled in this direction and now this body will have a tendency to once again move towards its mean position, because the restoring force, because this has stretched, the restoring force will be in this direction. If the restoring force is in this direction, restoring force is to mass into acceleration. So it means the acceleration is also directed this way. The displacement is in this direction, acceleration is in this direction, so they are opposite directed. And the same thing is applicable when the body goes from here to here. When this goes from here to here, so what has happened is the body has gone over here from here to here, but this spring now is compressed. So as a result, this will push it this way. That is, restoring force is once again towards the mean position. Restoring force will mass into acceleration, so it means acceleration is once again directed towards the mean position. Displacement is in this direction, restoring force or acceleration is in this direction. Once again, they are opposite directed. A is proportional to minus displacement. Acceleration is proportional to minus displacement is sufficient condition to prove that this motion is SHM. So acceleration is proportional to minus displacement is necessary and sufficient condition to prove that this motion is an SHM.